The 6 weeks common assessment, number 1, 2, and 3. It says, refer to the ellipse represented by this equation here. The first thing we need to do is find the coordinates of the center, then we'll find the coordinates of the foci, and then we'll find the coordinates of the vertices and covertices. To do so by hand, first, we need to get it in the correct form. Now, what does the correct form look like? If we pull out the formula chart, we scroll down to ellipses down the bottom of the front page, you'll see ellipse comes in this form or this form here. So we need to have this equation equal to 1. There should be a positive symbol between the x squared and the y squared. So I come over here and I notice that there is a positive. They're both squared, the x and y, but there's no fraction. So here's what we do first. We need to set this equal to 1 by dividing everything by 81. When we do so, we get the equation we're actually going to work with, which is y minus 8 quantity squared over 81 plus x plus 4 quantity squared over 81 divided by 81. This part right here cancels, so you're left with just 1. And this will equal, over here, that also cancels, and it leaves us with 1. Now, if it's equal to 1, this part will normally just disappear. But if it's easier for you, you can leave that there just as it is. Now, the coordinates for the center come from the top part inside the parentheses. So anything on the inside of the parentheses will always go opposite if it's with the variable. So this is saying we go up 8 for the center, and this is saying we go left 4. So my center should be located at -4, comma 8. And that would be the first answer here. -4, 8. Or I guess I could put it over here. -4, comma 8. The foci, if you remember, that comes from, the foci is always with the letter C. So this is with C. And to find C, we use the formula C squared equals A squared minus B squared. Unfortunately, that's not on the formula chart, so you just need to know that. Have it memorized. So the A squared, when you look, it's the bigger number. So this, in this case, this is the A squared. This is our B squared. So we plug it into the formula, and we would say that it'd be 81 minus B squared is 1 equals our C squared. So C squared, it looks like, equals 80. So what would C equal? C would equal plus or minus the square root of 80. Because anytime you take an even root, it needs to have plus or minus. If we wanted to simplify this, use upside down division, or you could find factors that go into it. Now I know 2 goes in 40 times. 2 goes into 40 20 times. I know that 2 goes into 20 10 times. And 2 goes into 10 5 times. These are all prime numbers. And now I'm going to just circle up some pairs here. And so I have a pair. I say circle, I should say oval or ellipse here. That's a pair. That's a pair. Pairs go outside the radical. So I have a 2 times 2 on the outside of the radical, which would be a 4. Singles go right back underneath the radical. So this is 4 square roots of 5. So my foci would be plus or minus 4 square roots of 5, because that's what I had the plus or minus there. So let me rewrite this a different way. Let me say this way. C equals plus or minus 4 square roots of 5. And that would go from my center. Now, we need to know if it's up or down. Since the y has the bigger number, the a, the foci are going up and down. So from the center, I need to go up and down, which means it would be with the y value. Since the bigger number is with y, I'm going to add the c and subtract it from my y. So my x would not change, but I would have 8 plus or minus 4 square roots of 5 for my foci. This would be the exact location of them. When I say exact, I mean exact. There's no rounding there. That's exactly where that foci would be located. And again, I could write these over here. So it'd be left 4 units, and then you would go to the center, which is at 8, and then you would add and subtract 4 square roots of 5 to it to find the foci. Now finally, it says find the coordinates of the vertices and covertices. If you remember, vertices have to do with the letter A. Covertices have to do with the letter B. That's how A, B, and C are related. C is foci, A is vertices, B is covertices. Now we said A squared is 81, which means A equals, when you take the square root, plus or minus 9, because 9 is a square root of 81. So A squared equaled 81 So that's where we got a equals the square root of 81. The b, we know that b squared equals 1, so b would equal plus or minus square root of 1. I forgot the plus or minus here. And so that means b equals plus or minus, what's the square root of 1? 1. So the vertices, since that's an a, you go to the bigger number, which is the y, and you're going to add and subtract it to the y. So my vertices would be, I'm going to add this to the y value, so it would be negative 4, 8, plus or minus 9. That's my vertices. The co-vertices would be a little bit different. They would be, since they go with the x, the b is with the x, it would be negative 4 plus or minus 1, comma, 8. So notice how these work. The vertices would add with the y, because that's the bigger number. The co-vertices would add with the x. So here, my actual answers, if I wanted to write them out, I would add negative 4. And this I'll solve out since they're easy numbers. 8 plus 9 is 17. And the other would be negative 4. 8 minus 9 is negative 1. There are my vertices. My co-vertices would be negative 4 plus 1, which is negative 3. And negative 4 minus 1 more, which would be negative 5. Those would be my values. And I'll circle these up. Now, could we have done this in the graph? Answer, yes. Everything but the co-vertices would have been exactly given to us. So let me show you how we could have done the graph. I'm going to go back here, and I'm going to graph this equation. So I'm going to open up my calculator, and a new document just to clear everything, and I'll make it a little bit bigger for us. We go to graphs, we go menu, graph entry, choose equation, find ellipse. So we have this. Now it asks for the value of shift with the x. Notice it puts in a negative. So we want it to be positive 4. To make it positive 4, you must hit negative 4 because it's a negative of a negative that'll turn it positive. Go over here to the y. The y value, remember how it shifted up 8? That was because it said negative 8. So the negative is already there, just put an 8. Now we go underneath. We had 81 underneath the y squared. The calculator has a squared, so you can either put 9 or you can do square root 81 like this. Oops, 81. That way, those just cancel out and it looks exactly like our equation did. And I can go over here and we could do the same thing, square root of 1. That way these two cancel out and our equation should come out perfectly. Now I'm going to scroll out. Here's my center. And if I want to know what the calculator thinks about the center, I can go menu, analyze graph. I choose analyze conic. Hit center. When I highlight it, it says it's negative 4, 8. That was our center. The next thing it asked us to find was the foci. So I go analyze graph, analyze conic, foci. And I hit the button. It'll give me the two values. I'm not sure exactly right now why it's not plotting. Those are them, though. Well, I don't know why it's not. I'll have to try it in a second. And finally, analyze graph, analyze conics. I'll go to vertices. I hit that. Again, I don't know what I'm doing here, but there they go. So the foci are given here, and that's my vertices. Now, it doesn't give us co-vertices, but co-vertices are these ones that, let me get this so we can see it, so we can see these values. So that's the other foci. This was our other vertice, which is just like the values we put a second ago. If you need co-vertices, one thing you can do is you can go to Analyze Graph, Analyze Conic, and you can do like axis of symmetries, and this will cut it in half, and you'll see the exact points where they cross. That this would be a height of 8, and you could go down here and see, oh, that's left. It looks like about 5 units, or another way of doing it is we could just trace it, and you could come around and look for what that point is. Right here where the co-vertices should be, it says negative 3, 8, and again, that was what we had for one of our co-vertices, so we did do this correctly.